Okay, first lesson. Hopefully this is a little bit of a revision for you guys, but I never trust that. I always want it to be taught my way. So here we go about what simultaneous equations are. So previously, from year 8, you're shown how to solve linear equations with one variable in them. For example, can someone help me solve 2x plus 3 equals 7? I want x by itself. So what would I try to get rid of first?
The number on it.
Yes, you want to try to get the, not yet. You need to go in reverse bedbas order, so you get rid of the 3. So what's the opposite of adding 3 to something? Taking away 3. So you're going to be, take 3 from both sides. 7 take 3 is going to be 4. Now you can get rid of the number on it. What's the opposite of timesing something by 2? Dividing by 2. So divide that by 2, divide that by 2. That's going to cancel. So x is going to be 2. You should be able to solve that ever since the start of year 8, depending on who you have. However, when there's 2 variables, you get stuck. If you try to use those strategies that you've learned from year 8, you cannot do anything here, because if I tried to solve that, if I wanted to find x, what's the opposite of adding y? Taking y. So you're going to get this answer that says 9 take y. Am I any closer to knowing anything yet? Because I don't know what y is, right? So right now, up until this point of your understanding of algebra, you can't actually solve anything with 2 variables. However, if we have another linear equation that relates to the same variable, we can find both x and y. When multiple equations refer to the same variable, they're called simultaneous. How do we show that equations are simultaneous? We group them up using these curly brackets. I'm not going to mark you down if your brackets look dodgy. Mine look dodgy, but it's just like if you look on your keyboards, if you've got them open, it's the brackets next to the P key on your keyboard. They're a little curly, yeah? So what does the curly brackets show? This shows that the x and y in both equations are the same variables. So to help you out, so that we can do a situation where you can see the application of this, let's do a example situation. Bridie wheel kicks is new to the school and doesn't know the prices at the canteen, but sees that his friend Lucas bought 1 pie and 1 sandwich for $9. And his other friend Roberto bought 2 pies and 4 sandwiches for $24 in total. And he's a bit scared to go into the canteen and actually look up the prices. So he asks his friends instead. If Bridie lets x be the price of the pies and y be the price of the sandwiches, can we make up some algebra to talk about Lucas's purchase? How many of each thing did Lucas buy? 1 of each. And didn't we just say that x is the price of a pie?
Yeah.
So it's going to be 1 times by x for Lucas. Which, do I need to write the 1 in front of the 1x? No? So Lucas is going to be x plus, how many sandwiches did Lucas buy? 1. And how much did that price equal? No. We have an equation. If that's the only info that I had, I cannot solve that. However, we had another friend, Roberto, that bought 2 pies. What algebra could I write for the purchase of 2 pies? 2x plus, what would his sandwich purchase be? 4y equals, and the total? 24. Do both of these equations refer to the same x and y variable? Yep. Therefore, because that is the case, we can write this. How do I indicate that 2 equations are simultaneous? What is the thing that I write in front of them? The curly brackets. So I do a little thing like that. And I'm saying that the x and the y in the x plus y is equal to 9. And the x and the y in the 2x plus 4y is equal to 24. They are the same variables. All right? So I'll pause that there. Give you some writing time to write down that example situation so you understand what simultaneous equations represent.